I know it's been a while. This has not been like best first half of the year, let's say it. To keep it short, I had some apartment issues. This is not the same apartment as you can see. Some roommate issues, some depression issues in general. I usually don't like to use mental health and mental condition as an excuse, because it is not. It's something that happens to everybody. So I'm just taking all of that, knowing that I feel a lot better right now, and trying to get back into this business because I still have a lot to say. And unfortunately, the last video left so many things that need to be carried through. This is a very important subject, actually. Me as a scientist, as someone with a scientific background, better said, this is something that is incredibly important to me. Of course, as a queer person as well. I don't know if you noticed, but I'm a little bit... But let's get back into the subject. We were talking about science and how the scientific method works, and how you can actually figure out if someone is talking scientifically, rigorously about something scientific in the proper way, or if that person is actually trying to advance an agenda utilizing science and scientific terminology to advance such to the point where you can actually recognize pseudoscience very quickly the moment that you realize that the methodology is flawed, that the terminology is not well used, or if you see that something is biased. So to recapitulate what we talked about in last video, and to add a little bit to what we have already discussed, let's remember the following things. First, science differs from faith and belief in a very fundamental perspective. While faith is a personal experience, science is precisely the contrary to that. It's an universal experience. It's a total opposite of a personal belief. Science focuses on universal observations and proofs that anyone can get. Number two, a scientific proof needs to be verifiable by anybody who wishes to do so. Otherwise, it's not a proof. Number three, the scientific method is the way that we try to take out any possible bias that we could introduce when we are studying something. Any other method will yield results that are strictly philosophical or empirical in nature. Number four, and this one is really important, to speak hypothetically means to propose an explanation to a phenomenon based on our previous knowledge or a brand new idea, whereas speaking theoretically means to extend the knowledge that we already have and agreed upon to explain something new, or to try to, refine our models and methodologies. For example, in the context of general relativity, we can speak hypothetically about gravitons being the particle that is going to mediate gravitational interactions in a quantum level, but we can also speak theoretically that the gravitational waves that we have observed, that we can finally detect, are actually the physical manifestation of those gravitons. Hypothetically, gravitons exist, but we have absolutely no proof of that. Theoretically, gravitons would cause or be the expression of gravitational waves in a quantum level, and we have detected them, we know they are there, and we have a model to try to explain and relate both concepts. So that's why that's theoretical, whereas speaking about the graviton in general is only hypothetical. There's no proof. And number five, we can generalize the application of the scientific method the following way. First, observation. Then, confirmation of those observations. Then, formulating hypotheses to try to explain our observations. Then we're gonna bundle up those tests, experiments, and confirm or accept as hypothesis into a theory. And then finally, we're going to reiterate and start from the beginning and try to test and challenge the theory that we have just proposed. Because the scientific method actually demands a constant reiteration of itself in order to get a more perfect answer. So I hope that you can begin to understand how monumental this task is. In fact, most scientific studies that we see day to day focus on only one of those steps, sometimes even more focus inside of that. Try to collect data or to test the data that we have already collected before, or maybe introducing a new variable that we weren't able to measure before because we didn't have the tools or we didn't have the proper theoretical framework to do so. But generally speaking, it is basically impossible for one single scientist to complete and follow the whole scientific process by themselves. This is why we say that science is a collective effort. We need a community, a scientific community, in order to actually advance science, because an individual cannot. And this is very important to always keep it in your mind and remember that, because sadly, many among us think that honestly, one single scientific report or study made by one single group in one single occasion is enough to change our understanding of nature. When scientists, at least the good and professional ones, when scientists talk about confirming or denying something, it's because they have gone through all of the conceivable ways that they can test their hypothesis. And not only by themselves, but also by their peers, because any hypothesis needs to be tested by everyone, and everybody should get the same results. That's the only way that we can guarantee that whatever it is that we are proposing as an explanation could actually be valid, because it doesn't depend on the person who's doing the observation. It's just the way it is. And yes, some experiments, some single experiments done by a single experimenter have given us in the past some big breakthroughs and a lot of information and a lot of new amazing knowledge has been unblocked by single experiments in the past. But that's not the way science works really, and especially not modern science, where you need the input from so many different fields. I mean, all of our scientific knowledge is really built on previous knowledge that we keep constantly revising and improving. But enough about cold and hard science. Let's get a little bit more human here. You see, we as people, as humans, we forget sometimes that we are also part of nature. All of us individuals, and as a collective, we are also part of a natural system. We call that system society. And we need to remember that any system, natural or artificial, can be modeled and studied scientifically. In other words, we can understand the rules and the trends within that system if we apply the scientific process to it. Now, the complexity of that system, society, is of course greater than the complexity of the system that we studied before, when we had only two charged particles. But that doesn't mean that we cannot find a physical analogy to society in general. We only need other tools and other skills to understand it. Up to the present day, I have been lucky enough to live in 4 different countries. And I can attest that one of the least discussed, and in my case, it's not explained enough, subjects and scientific tools for basically any kind of scientific study is statistics. And this lack of knowledge, in fact, the lack of general understanding of statistics and statistical results, is one of the main difficulties to overcome when trying to explain a scientific study to someone without a scientific background, and even to those who have one, honestly. However, comprehending statistics is key to any sort of science study because, as any scientists know, there is no such thing as a perfect measure. I mean, we will always have some sort of error when measuring, when using a new equipment or an old equipment, when testing a new theory or an old theory, when using our eyes or somebody else's eyes. There is always going to be some error bound to the measuring that we are doing. So by taking multiple tests, we can sort of cancel out all of that noise in the data through statistical analysis. So what I mean is that a statistically valid result is basically key to the confirmation or denial of any sort of hypothesis, either in the natural sciences like physics, chemistry, biology, etc., as well as in the social sciences. Formal sciences like mathematics work under a similar framework, but since the mathematical proofs are not something that we can touch, are not tangible, meaning that we cannot make experiments with them, we cannot touch mathematical objects, we use a different terminology for them, like axioms or corollaries or theorems, but the methodology is pretty much the same. Now, only with that, we have the most powerful tool to understand and explore social phenomena. Now, of course, unlike atoms and molecules, people are not discrete units that look and behave the same way. What I mean is that if you take a glass of water and you randomly select one single water molecule inside of it, you can be pretty much sure that the vast majority of its properties are going to be identical to all of the water molecules that were around it. The same cannot be applied to people. I mean, people are not discrete sociological objects that will act all the same, even if they are part of the same cultural or societal group. People don't always react the same to the same stimuli, nor with the same intensity, and stimuli can have also side effects that we need to take into account. So, turns out that people are more complex than molecules, go figure. That doesn't mean though, like I said before, that we cannot find some sort of physical analogy to help us understand what it is that is going on with society. So let's take a little mental experiment. Let's imagine a sealed room filled only with hot water vapor, with some instruments plugged in to measure what's going on inside. Now, let's imagine as well that we've got a way to track each individual water molecule inside our system. Thus, we can know where they are going and how fast. What do we see? Well, we see a distribution of velocities inside that room. Some molecules are going really fast, others rather slow, but most of them are somewhat in the middle. And as many of you must know, moving things have energy. We call it kinetic energy. So this distribution gives us actually a window into the energy of our water vapor. So that means that we can define this aggregation of the distribution of individual velocities as a new variable that describes this system. And guess what? We do. We call it temperature, aka the complex sum of all the kinetic energies of all the molecules in that vapor. And I say complex sum because of course it's more complicated than 1 + 1, but you get the gist. Let's really grasp that for a second. A property that we can see, that we can measure, that we can feel, and that is actually part of our most basic of experiences day to day, temperature, is in reality the product of millions upon millions upon millions of individual interactions and properties. In this case, kinetic energy. We apply statistics then because we can study these kind of properties, this kind of emergent properties in a system without having to worry too much about the individual behavior of one single molecule, but we still acknowledge it. This is what we call mechanical statistics, and is the most fundamental tool to understand thermodynamics. Do you see the analogy now? Replace water vapor molecules for humans, and we'll see that people and societies tend to act the same. What I mean is that one single individual cannot be representative of a whole community or a whole society, because the rules, the characteristics and properties of that society are defined by a complex interaction of rules, characteristics, and properties of millions, sometimes millions, of single individuals. In other words, we can apply statistics as well to human societies to model and to understand a whole population without taking into account the individual response of one single human, the same way that we can do in physics a statistical treatment of a system to understand something that is composed by trillions upon trillions and trillions of molecules. And this is what concerns social sciences in general, like psychology, sociology, anthropology, etc. Now, it is true that in the past, some unethical and immoral practices in the scientific community used to be the norm, and sadly we can still see them today. But we need to understand that that doesn't demerit the work or the science that is done within this kind of fields. This is not a social sciences problem, this is a people's problem. If we cannot agree on what's ethical or not while conducting an experiment, maybe we shouldn't conduct it at all, at least until we have a general agreement and understanding of the possible consequences of any sort of study. Let's always remember the big nuance that it's not the same to apply stimuli to physical systems composed by molecules than applying stimuli to human beings, which are also a natural physical system, but we're also people. We have feelings. But ethical problems aside, the statistical rigor that is applied to social science is very much the same that is applied to all natural sciences. But the variables have a different complication associated with them, like ethics, but also the fact that social concepts tend to be even more blurry in their definition than non-human cold, just perception or observation related properties. For instance, it's generally easier and more intuitive to understand why if we introduce a temperature trap inside our mythical water vapor room, then the distribution of energy and different temperatures is going to be altered in a different way according to the filter that we are introducing into our system. That is easier to understand than social inequality or the patriarchy, and that's okay, that's fine. We have a harder time grasping those concepts because we ourselves are part of that system. In other words, in natural sciences like physics, chemistry, etc., we have an easier time detaching ourselves from what we are studying. We are mostly not involved in the phenomenon we are studying. Neither are our opinions, our views, or our beliefs. We're just observing nature being natural. The logical fallacy here is to think that humans and humanity are something other than a natural system. This leads us often to try to apply our own ideas and experiences about how people work without recognizing that this is introducing a personalized bias into whatever we're trying to study. Of course, the people that study these subjects for real the real professionals and experts in these fields spend years and years learning, obtaining, and mastering scientific tools for analysis and interpretation that will curb or totally avoid these kind of biases. But us, the regular people, the general public, we do not. So it's really not that surprising that if there are some people who apparently have such a hard time understanding or accepting the science behind the most basic of facts, like the shape of the earth, that we will have always some people who would be diametrically opposed to the discussion or the introduction of new social insights, the revision of old concepts, or the calls to discard or to, change the way that we treat some other human beings. Only a few decades ago, for example, homosexuality was seen and treated as a mental illness. Only after a countless amount of scientific studies, many of them trying to support that homophobic idea, we now know and we have accepted in the scientific community that homosexuality is, at the very least, in the most rigorous of jargons possible, a completely natural human phenomenon. And it's something that will arise in each and every society group, regardless of its size, its cultural background, its experiences, its beliefs. It doesn't matter. We will be there. In fact, this absoluteness of the presence of homosexuality in each and every single kind of society group is what suggests that homosexuality is actually a natural process, that is something defined by our biology in a very complex way, and that there's no absolutely any way that can be changed by any sort of external force. Now, it took a very, very long time for scientists to start dropping their biases and to begin studying homosexuality as a natural process, as a phenomenon that needed to be studied. And of course, it took an even longer time for the general society to start accepting those scientific facts. I mean, homophobia is still everywhere. So we still have not solved that issue. We do have more visibility, recognition, and representation, and we are more protected than ever before in some countries, but again, not solved yet. Now, this creates a conundrum, let's say, for people like me, who like and really love discussing and debating these kinds of scientific subjects and theories, but who also have a very short fuse when faced with logical fallacies. I mean, I like to talk spirituality, metaphysics, religion, and personal growth as much as any other person in the world. But I really hate when people begin to mix one thing with the other. There is no room for personal belief in science. That is precisely the point. That is exactly the point. That anybody, regardless of their credence, their origins, their life experiences, their anything, can and will get the same explanation and conclusion that you did, following the same process, the same methodology. And I have not, unfortunately, the patience nor the capacity required to make someone understand this nuance. I don't blame anybody that loses their temper when someone tries to justify bigotry with the manipulation of scientific jargon, concepts of ideas or data or whatever. For example, on my last video, I discussed an author whose writing is about being transgender as a trend, as a dangerous trend that is trapping and tricking young girls. She argues that the number of cis female-born people that choose to go through a transition process has catapulted in the last years. And she even collected some testimonials from people that regret going through transitioning or who have actually detransitioned afterwards. She argues as well that all transgender people suffer from gender dysphoria and that the media is actually selling transitioning as one of the best solutions to many of the obstacles, hardships, and dangers that you can face as a young girl in our lives. So you see, the real harm and deception behind this argument is that many people take them as a logical conclusion because they don't have a notion or a full understanding of statistics and scientific analysis. This, together with the fact that these are kind of touchy subjects, sexuality, gender, identity, all of that is helping this person to create this false narrative utilizing scientific jargon in a totally unscientific way. I mean, personally, to me, her turfy arguments are as nonsense as trying to equate being trans with being gothy or emo, Like, we've always known gothy people. There have always been people, that find an attraction or a fascination by the dark, by the macabre. There's nothing new, but it is arguable that at least in 2 occasions that I have lived through, being gothy or emo was actually trendy, was actually fashionable, even if the vast majority of people never got into it. Back in the day, I was one of the first ones to blast My Chemical Romance and dress all in black with like eyeliner and whatever. So what I mean to say is basically that it wouldn't surprise me if there are some people who actually believe that's how it works, It's just kids being dramatic. It's just doing crazy and silly things like getting in person or dressing a certain way or frequenting, like a group of people. But it's only a phase, They'll grow out of it. So trying to suggest that an aesthetic for self-expression and gender non-conformity are the same thing is basically a really good example of a biased and pseudo-scientific narrative. There are no previous studies to support her arguments, and the ones that she introduced are in the same vein as hers. What I mean is, they are trying to present and frame numbers in a way that would lead the reader into that same conclusion that she has, what I call the Prager U strategy. Now, there are 3 signs that you are following a Prager U strategy. The first one is no description of methodologies, neither on her book nor on the sources she references. Then, she tries to make us think that a handful of examples is enough to describe a population of millions of individuals, which is statistically wrong. And lastly, she presents absolutely no challenges to her own hypothesis. Any good scientific study needs to say, well, we need to test for this and this and this because this could bring all of our ideas down. That is important. That is vital in science. In summary, she posts numbers carefully selected to support her agenda and her reasoning, which has nothing scientific about it at all. And that could be fine with me. Like I always say, if you desire so bad to be a bigot, go ahead and be a bigot. If it's your calling, it's your destiny, if it brings you pleasure to discriminate against other people, fine, be a bigot. You do you, girl. You do you. But this is a really, really big but. Don't come calling your bigotry science-based, because there's nothing scientific about manipulating numbers to create a narrative, to hide different studies that contradict you in order to support your point. If it's a fact of nature, no amount of manipulation and misinterpretation will last forever. The weight of proof will always bring down that house of cards argument to the ground. Always. Bottom line, and take this as an advice. Don't try to push and force on scientific arguments. You will look very silly when they come down hard after being faced with the slightest of logical or evidential scrutiny. So that would be all for today. Now, on the next video, that should come out in a couple of years if we follow this publishing trend. But no, on the next video, we will finally speak scientifically about homosexuality, transgenderism, and queerness in general as a two-dimensional subject, because we need to remember that this is both a personal and a societal subject. So I really hope you join me and have some patience to wait for that video. It should be good. It's already written. I just have to find the motivation to and better lightning. But anyway, thank you so much for joining and hope to see you next time.